Welcome back to the Scotti-BYTE channel, and this is Scott. So we're going to continue talking a little bit about storage after we had the video on virtual disks. And today I want to talk about iSCSI. So iSCSI stands for Internet Small Computer Systems Interface. And iSCSI is block-based storage, whereas Microsoft CIFS or Linux NFS are files-based storage. And an iSCSI initiator is an endpoint client that initiates an iSCSI session to access bulk storage. And an iSCSI target is the server that is actually hosting that storage. And iSCSI storage looks like SATA or NVMe storage because it's block-based with the partition table and formatted partitions. So iSCSI storage is a little bit different than what you're used to, but actually it's a whole lot like storage that's locally on your machine, like a local hard drive. So iSCSI is SCSI protocol over TCP/IP and was invented by IBM and Cisco in 1998 and became a draft standard in 2000. And it's been used for quite some time and mostly used by businesses, but it works out really well in the home lab if you need some high-speed bulk storage and don't want to have to buy additional drives for your system. So SCSI over Fiber Channel was really the first implementation of SCSI over a transport interface, and they became known as Storage Area Networks or SAN networks. And Serial Attached SCSI, or SAS, uses a SCSI command set as a point-to-point serial protocol. And in fact, a lot of businesses don't use SATA drives. Instead, they use SAS drives in their storage arrays. So iSCSI block-oriented storage can perform random access I/O, whereas your protocols like the SMB or NFS is a files-oriented protocol, and it's best only for sequential access. iSCSI can host multiple connections to a single target, but that's normally not done because iSCSI does not implement any sort of file or record locking, and you would have to count on the program accessing the data to do its own file locking. For the purposes of this demonstration, I have created two virtual machines, and both of them are using Ubuntu 23.10 codename Mythic Marvel. To begin with, we're going to start on the target machine, which is the server. It's the thing that's going to be offering the storage over to the initiator. So on the target machine, if we do an lsblk, we can see that there is an SDA device and an SDB device. So the SDB device over here is going to be our iSCSI storage, and it is a completely uninitialized, unformatted, no partition type disk. The next thing we need to do is we need to do a sudo apt install tgt, and tgt makes this machine an iSCSI target. After installing tgt, we can do a sudo systemctl status on tgt, and you can see that it is loaded, active, running, and enabled, which is what we want. To configure the target, we need to do a sudo nano /etc/tgt/conf.d iSCSI.conf. And in this file, I have a configuration which basically describes the LUN. So the LUN is IQN, which is Internet Qualified Name, .2023-11. Those are just arbitrary things I'm putting in to remind me of the date that I created the server, and .my.server. And then after the colon is going to be the name of the particular disk. So I'm calling my disk my 10 gig or my 10 G. The backing store is where we want the storage to come from to support this. And you'll recall when we did the LSBLK, we had a /dev/SDB which was available. And the initiator address is the IP address of the system that is going to be connecting to this target in order to access the storage. And an incoming user, this is a username, and we're just giving it iSCSI-user. You're going to want to pick something a little bit more unique. And then I'm picking a really complex password of PA55W0RD. You probably want to pick something a little bit more subtle. So if we do a Control-O and hit Enter to write that configuration out, and a Control-X to exit the nano editor, we're good. We want to restart the target service with a sudo systemctl restart tgt. And then we want to do a sudo tgt adm space -- mode target space -- op space show, and it comes back and gives us information about our target and our user account and our IQN, or basically the information for our iSCSI LUN. And so all of that is verified as correct. So now we're over on the iSCSI initiator, which is the client or the thing that's going to connect to our iSCSI serve storage. First thing we want to do is do a sudo apt install open -iSCSI, and I'm doing the -y so I won't be prompted to say that yes, I truly want to install this. So it goes off and installs the iSCSI server. Now we can do a discovery command to see whether or not we can see our iSCSI server, and we do that with the sudo iSCSI adm -m discovery -t st space -p, and then the IP address of the server, and it comes back and gives us the correct LUN. Port 3260 is the default port for iSCSI communication. Now that we know that we can talk to the target server, we want to do a sudo nano /iSCSI /initiator name.iSCSI. That comes up into this particular file, and we want to add a line that says initiator name equals, and then we want to put in the IQN that we got from the last command. Once you've done that, we can do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. Now we want to edit the iSCSI configuration file on the initiator, and we do that with the sudo nano /etc /iSCSI /iSCSID.conf, which is the daemon file for that server. When we bring this up, we want to go ahead and scroll down the screen, and we're looking for iSCSI startup, and it says node.startup is manual. We want to change that to automatic, and the reason for that is because anytime that this particular machine boots, we want it to be able to connect to the iSCSI storage that we have defined over there. As we move further down the screen, we're going to find the section that says node.session.auth.username. We want to uncomment that, and we also want to uncomment the next one, which is node.session.auth.password. So you'll remember that our username was iSCSI-user, and our password was PA55W0RD. So now that we've set those up, oh yes, and the other thing that I almost forgot is we need to come up here to where it says node.session authorization equals CHAP. So we want to uncomment that also. CHAP is the Challenge Handshake Authentication Protocol, or chat for short. And once we've done all of that, we can go ahead and do a Control O and enter to write the file out, and a Control X to exit the Nano editor. Now that we've finished the configuration, the only other thing that we need to do is we need to restart the services. So the services we need to restart are iSCSI daemon and open iSCSI, and we do that with a system or a sudo system ctl restart iSCSI D and open iSCSI. We want to make sure that our iSCSI session is operational, and the way we do that is with the sudo iSCSI ADM --m session -o show. And it comes back and says that it is in fact connected, and there's the information indicating that that's the case. Now if we do an lsblk, we should have more than just SDA, and notably we do now have the SDB device, which is the disk being shared back from the iSCSI server. We can also look at this graphically by launching gparted, and if you don't have gparted loaded on your system, you can always do a sudo apt install gparted, which is the GNOME graphical interface to the partition manager. And in this case, if we click up here, so this is our system disk here, and it has the UEFI partition and also the root file system. But if we click on this down arrow, we then also have SDB, and you can see that of course SDB is completely unallocated, hasn't been set up. I could come up here and say create a partition table and then create partitions. But rather than using the GUI, we're going to go ahead and do this all from the command prompt so you can understand the commands independently. Since the disk space being served back from the iSCSI target has not been initialized, we're going to go into fdisk by simply doing an fdisk space /dev/SDB, and this is just as though that disk was local to our system. And you notice that it gave us a permission error, and the reason for that is because I needed to have done a sudo fdisk. So now I do a sudo fdisk, and the first command we want to put in is n to create a new partition, p to create a primary partition, and we're going to default to partition 1. We hit enter, and the first sector is going to be defaulted to 2048, as they say, and the last sector will be the last sector on the disk. And I go ahead and do a W to write that out. So the partition table has been set up on the drive. The next step that we want to do is we want to go ahead and mount, or we want to go ahead and create a file system on that. And we're going to do a again, a sudo mkfs.ext4 to /dev/sdb1, because it is the first partition, and that's why we include the 1 here. So that goes ahead and writes out successfully. Now we want to take note of this file system UUID, because we're going to need it to mount it in the file systems table. So assuming you made a copy of that, we're going to do a sudo nano on /etc/fs tab, which is the file systems table that is used to mount the disk when the system boots. And so the command that we want to use in order to mount our iSCSI device will be this UUID equals that long UUID /MNT/my10G, and then ext4_netdev, which tells it it's a network device, and then 0 and 0 out here, which are for the log files. So go ahead and do a Control O and Enter to write the file out, and a Control X to exit the editor. Well, there's one step that I missed here that we need to be able to do, and that is a sudo makedir on /mnt/my10g, because that mount point does not yet exist. And then if I want that to be writable for the Scott account, then I could always do a sudo chown on Scott space /mnt/my10g, and that way I own that entire device. Otherwise, I'd want to go in and create user folders and assign the user folders to the ownership of the particular users on a multi-user system. So let's go ahead and bring up gparted again by opening the app drawer and clicking on gparted and typing my sudo password. And when gparted launches, we'll go ahead and point to device SDB, and you can now see that SDB is clearly formatted, but it's not yet mounted, and it will mount when we go ahead and reboot the system. So I'm going to come over here and do a restart, and when the system restarts, it should be automatically mounting our disk drive. Now that the initiator system is rebooted, I went ahead and brought up a Nautilus file manager and navigated to /mnt/my10g. And of course, I can create a folder over here, call this folder test. I can move inside a test, and I can go ahead and create other things in here as well. And I can also bring up a terminal. And in the terminal, I can do a df command. Let's make that a little bit bigger. And we do the df command. You can see here that device /dev/SDB1 is mounted through /MNT/my10g, which means that it's automatically connecting back to the iSCSI server, and it is associating the storage on the iSCSI server, and it is mounting here. And of course, the mount took place through the editing of the /etc/fs tab file. So we have our file system up and running and accessible. And one last thing is we can go into gparted again, provide our sudo password, and in gparted, if we move over to that disk now, we can see that it has got the key, which indicates that it is currently mounted, and it's an ext4 file system. It calls out its mount point as being /MNT/my10g, and it says it's used 249 megabytes, which is pretty much the overhead that it has, and the unused space on it is 9.07 gigs, and the formatted size is 9.31 gigs. It's worth pointing out that commercial NASs like Synology and QNAP give you the ability to make them iSCSI targets. And you can also use softwares like OpenNAS and FreeNAS to define iSCSI LUNs and become iSCSI targets as well. In this particular demo, we just used two virtual machines running Ubuntu, and we set one up as the iSCSI target. And of course, the machine we're on here is the iSCSI initiator that's making a connection to the disk space offered on the target. It's also possible to use virtual disks as iSCSI space. And if you watch my video about the virtual disk management, which is a couple of videos ago, it goes into that, but the technique is pretty much the same. So in summary, iSCSI is a use case for databases and applications that require raw direct I/O access. And for some applications, an iSCSI LUN can be faster than accessing a network file service such as CIFS or NFS. An iSCSI can be slightly faster, but it puts a load on the CPU in order to implement the protocol. iSCSI works for virtual machines and bare metal systems, but it does not work for LXD containers, which have no direct access to the hardware. And recall that LXD containers share the kernel from the host, and for that reason, they cannot obtain privileged operations to directly control hardware. And that's why iSCSI is not an implementation that is used inside of a LXD container. That being said, you can certainly have an iSCSI implementation inside of a LXD virtual machine because it is a virtual machine. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.